Hello again. So in this video I'm going to be discussing the derivatives of polynomials. So just to keep you guys aware, derivative is supposed to represent the rate of change for a specific point on a function. So say I have a function that looks like this, and I call that f of x. Allow me to pick a point on a function and draw a tangent line, a line that does not cross through the function, but touches the point. This is the derivative allows me to find the slope of that particular tangent line for that point on my function. So what about a polynomial? Recall polynomials, or p of x, is typically in the form a sub 0 plus another constant plus another constant x squared plus another constant x cubed plus how many constants and how many variables, where a sub n are real numbers. So for a polynomial, we could be dealing with constant terms, variables. So for example, a polynomial function we could be looking at is just x. We could also be looking at a constant, which is like 4, or binomials, x squared minus 9, or trinomial, x squared plus 6x plus 5. So all of these are examples of the type of polynomials. So how do we derive them? So there is something known as the power rule. Okay. So say we have a function f of x, or allow me to write it such that we can say that y is equal to f of x. Okay. Say that f of x is equal to x to some power. To find the derivative, or f prime of x, we use the power rule, where the original power becomes my new coefficient, and my new exponent is going to be 1 less than my original. Another way to write it is, say if you have y is equal to x sub n, my y prime, or my derivative, will be n times x to the n minus 1. Or we can write it this way, say if y is equal to x sub n, dy over dx is equal to n times x to the n minus 1. These are all just different notations in which to write derivatives. Also, keep in mind that if you have a function, f of x is equal to just a constant number, f prime of x is just 0. Also, if you have a function with multiple values, okay, we can find, or say I wrote it like y is equal to x sub n plus x sub n plus c, different terms. If I derive both sides, it's going to be d over dx, or the derivative of x sub n, plus the derivative, let me make that m, d over dx of x sub m, plus d over dx of my constant value. So I'm deriving d over dx, just means I'm deriving the function for x. So in other words, this would become dy over dx is equal to n times x to the n minus 1 plus m times x to the m minus 1 plus, and the derivative of a constant is just 0. A lot of this notation just seems overwhelming, so let's do an example. So let's say they give us a function y is equal to x squared. When I derive both sides, so dy dx is equal to d over dx of my x squared. In this case, my n is equal to 2, so my n minus 1, which is just my 2 minus 1, is equal to 1. So my derivative, replacing my values here, becomes 2 times x to the 1 power. This is my d over dx, or I can write it as y prime is 2x. There are multiple notations to talk about the derivatives, so just want to use all of them so you can get comfortable with seeing what they look like. Let's do another example. Let's say I have 4 times x cubed. Now keep in mind, if you have a constant, that constant can just go on the outside. So if I'm looking for d over dx of my function y with respect to x, I take the derivatives of both sides. Whatever you do to one side of the equation, you must do to the other side. And keep in mind that 4 can go out in the front. So that's 4 times d over dx, x cubed. In this case, I can just focus now on the power rule. I know that my n is 3 and my n minus 1 is 2. So this is just 4 times, so this is just 4 times 3 times x squared. Now we just simplify. 4 times 3 times x squared is 12x squared, which is my dy over dx. Let's do one more. Say we have, or we're looking for the derivative of a polynomial. Say we have f of x is equal to x to the 4th power plus 20x cubed plus x plus 9. If we want to find the derivative, or dy over dx, so my f prime of x is equal to d over dx for x to the 4th power plus d over dx for 20x cubed plus d over dx of x plus d over dx of 9. Let's go ahead and simplify. So my f prime of x is equal to, so d over dx of my x to the 4th power, taking out my constant, that's 20 times d over dx of x cubed plus d over dx of my x plus d over dx of my 9. So using the power rule, that 4 becomes my new coefficient, and that x now has 1 less than 4, which is 3. Plus my 20 multiplied by the derivative of x cubed, which is 3 times x squared, plus the derivative of my x. Now say you have x, the exponent, just to keep in mind here, x is just the same thing as x to the 1 power. So the derivative becomes 1 times x to the 0 power. Recall that x to the 0 power is 1, because anything to the 0 power is 1. And finally, I have a derivative of a constant, which we know is just 0. Why? Because a constant can be written as So 9 can be written as 9 times x to the 0 power because we know that x to the 0 power is 1. So when we do the derivative, that 0 goes out in the front, so that's 0 times whatever, which is just 0. Simplifying, we have 4x cubed plus 20 times 3 times x squared, which is 60x squared, plus 1 times x to the 0 power, which is just 1 times 1, which is 1. So, I hope this was helpful, and stay tuned for the next one.